Hello, welcome to our Data Mining Methods Group Project presentation. Let me take a minute to briefly introduce our team members. From the West Coast, we have Tyler Hines and Sabash Rangapur. Tyler lives in California, while Sabash lives in the Seattle area. Our third and final member of our group is Melissa Fazio. She is from Texas. Have you ever wondered how accurate Zillow's Zestimate price calculator is? After doing some research, our team found that their estimates were off by as much as $40,000. Some articles even state that Zestimate can estimate pricing within 5% of the actual price. However, that only happens 50% of the time, leaving a lot of room for opportunity here. So Zillow has launched a contest to build a new model to more accurately estimate pricing. Our team has accepted this challenge. We obtained our data from Kaggle.com. This data set was for houses in King County, USA, which is in the Seattle area. The data set contained 19 variables and 21,613 records. Our data contained the standard items we look for when buying or selling a home, such as price, number of bedrooms and bathrooms, and square feet. But it also contained items such as the view and whether or not it was near a waterfront. Additional items were also included in this data set that we had to mine through. Some of these items were zip code and even latitude and longitude. So we put our plan together and began moving forward. First, we had to assess the quality of the data and begin building our models to see if we could develop an accurate pricing model for Zillow using RapidMiner. During our data preparation phase of the project, we ran a correlation analysis in Excel prior to importing the CSV file into RapidMiner. In RapidMiner, we inspected the data for missing values and found that our dates were missing, so we corrected that and moved forward. Since we decided to use a decision tree, we also added price categories to our data file. We created two different files, one with price categories at $100,000 increments and another at $50,000 increments. After our data was prepared, we moved to the modeling phase of the project.
There are many software tools designed to facilitate data mining. We will be using RapidMiner for the classification model for this project. RapidMiner provides specific data mining functions such as decision trees, association rules, and many more classification techniques. RapidMiner is easy to install and will run on just about any computer. RapidMiner's maker provides a community edition of its software, making it free for readers to obtain and use. We will be using decision tree model here. RapidMiner provides a lot of operators. Here the first step is to read the CSV file. We have a dataset in the CSV format, comma separated file. So read CSV operator from where we can import the CSV file. If we would like to change any of the operator attribute types, we can change it here. So we kept all the attributes as default. Once we import, finish it, then we can run and we can examine the data. So whether there are any missing records or any other attributes, anything we would want to change, we can make those updates here. This dataset has a lot of attributes. We have total 19 attributes. We may not be needed all the attributes. There is another operator called select attributes where we can select particular attributes. So by selecting, so we can move attributes from left to right, so that the right indicates these are the attributes where we can make use of in the decision or feed these attributes to the decision model. Here we have selected price category, so where we can predict the data, predict the price of the house, bathrooms, bedrooms, square foot living, square foot lot, and zip code. One necessary data preparation step is to add a set total operator and define the price category attribute as your label here. So there is an operator called set roles. So like after reading CSV file and selecting the attributes, we can add another operator called set role here. And here the attribute we have selected is price category as a label. This is the final step for the training data set. So decision tree, so there is another operator we can add here. So we have selected the default parameters. Once after adding the decision tree, we can run the model. So there is a run in the rapid manner. So once we run, it gives a tree structure. Let us see in the next slide. So here is the output after running the decision tree model. So here the graph, it gives how the tree structure looks like, and also we can look at the tree how the prices are defined based on the living. So for example, square foot living, if it is greater than so and so forth, the price will be this much. So we can drill down and try to understand how the price will be defined based on those selected attributes. Once we create the decision tree model, so that model can be applied to any data set. So here there is a second data set where we created with 10 records to predict the price of the house. Again, read the CSV file and apply the set roles, and there is an operator called apply model. Once we apply and run that whole model, it predicts house price for those 10 records. Once we run the whole model, so it gives the prediction of the price category. So since we have the 10 records, so it predicted here the price category. So looks like all 10 records, it's predicted the same 300k to 349,999.
After receiving the prediction results from the decision tree model, we decided to take a further look at the accuracy of the model because each category came back the same, so we wanted to dig in and find more information. When we ran the accuracy of the decision tree model, we found that the accuracy was low at 57.80%, with most of the categories falling in at under 50%. This troubled us a little bit, and we decided to do some further digging and possibly try a different model. After doing some brainstorming, we decided as a team to give the neural network model a chance. We thought with all the attributes that we had, that decision tree model may not be the best option for us, and a neural network model might be a little bit better. So we decided to give it a shot and run our results. Luckily, there wasn't much that we had to do to change up the setup for testing the accuracy of a neural network model. All we had to do was change the neural net operator with the decision tree operator, and we were good to go. Right away, it was clear to us to see that the accuracy of the neural network model was going to be a lot more reliable than that of the decision tree model. When this came in at 88.99%, we were able to compare that with the 57% of the decision tree model. And we can see that in each one of these categories for the class recall and class precision, we're seeing results that are at minimum 50% and majority are residing at 75% or above. This gave us a little bit more clarity and a little bit more direction on which way that we should go with our project, and allowed us to pick a model that we believe is going to get us closer to predicting the type of data that we were looking for. When we first ran the performance for our neural network model, we were using increments of $100,000 for the categories. Basically what we were trying to find is if those houses fell in the correct categories. And then we started thinking a little bit more that $100,000 doesn't really get us closer to that precision or that precise number that we're looking for in predicting the price of a home. So essentially what we did is we decided to move down to $50,000 increments and see what our accuracy would be. And when we got the results, we found out that the accuracy went down to 31.48%. Majority of the class recall and class precisions were falling well under 50%. The highest was at 50%, and so we learned that as the categories got smaller, then we were essentially looking at the less likelihood of that being a precise or accurate estimation for what the price of the home should be.
In conclusion, our goal was to accurately predict what prices should be based on the attributes in our data set. We found this very difficult to do. As the data set provided a good reference, we concluded it did not tell the whole story. For example, we don't know and couldn't tell if one property value is higher than another, which is directly related to the price of a home. We also concluded that current prices for homes are not in the correct price category based on our data. Using a prediction data set, we found that each of the 10 houses should be in the $300,000 to $349,000 price range. Again, we didn't feel like this was an accurate representation of the true price. Additionally, our model could be modified by adding price categories in $1,000 increments, but it would result in at least 800,000 categories and could increase as it expanded across the United States. Lastly, Zillow could invest in our team and we could continue to build out those additional price categories and models for them. It is apparent that estimating or predicting the price of a home has many variables, one of them being the human factor that makes accurate computer modeling very, very, very difficult.